Good morning, students. So today we will discuss the last part of the lesson, that is dual nature of matter and radiation. So in the last class, yesterday, we have discussed about the Einstein's explanation. So according to Einstein, one equation we have seen. So what is that equation? The equation is relating the energy, kinetic energy and the work function, right? So yesterday we have discussed that point. Then after that, we discussed about the de Broglie hypothesis. So Einstein's equation, you can see here, Einstein's photoelectric equation, that is the kinetic energy max. K max is equal to h nu minus pi naught, where h is Planck's constant, nu is the frequency, pi naught is the work function. Okay, so which value they will ask, accordingly you can calculate that. That is by using the de Broglie hypothesis. Okay. Okay. So that is Einstein's photoelectric equation we have discussed. De Broglie hypothesis and the de Broglie equation also we have discussed yesterday. So today we are discussing, that is the last part, that is Davison and Germer experiment. Okay. So what is Davison and Germer experiment here, students? So what they will do and what is the confirmation of the experiment? So Davison and Germer experiment prakara, here we will get to know about the wave nature of the electron. We get to know about the wave nature of the electron. Okay, so till now we discussed about what, that is the light exhibits both particle nature and the wave nature anta helidvi, matter ಬಗ್ಗೆ discuss ಮಾಡಿದ್ವಿ. Now according to Davison and Germer experiment, what they will say, the electron exhibits the wave nature anta explain ಮಾಡ್ತಾರೆ. Okay, so according to the experiment, here the experimental setup you can see. Once again I'll share that picture here. So the Davison and Germer experiment. I think I'm not getting that one now. Okay, just roughly I'll show that. How that experimental setup is there. Suppose if you have a textbook, you can open and you can see that, no problem. Okay, so according to Davison and Germer experiment, here first there will be a high voltage battery is connected. So this high voltage battery then next connected to the rheostat. So here there is a rheostat. Okay, then next this is connected to a electron gun. So then next it is connected to the electron gun. So with the help of the electron gun, here what is happening? The electrons gun andre en ಮಾಡ್ತಾ ಇರುತ್ತೆ. The electron beams are coming out of this. So ಇದೇನ್ electron beams are coming out of this, it will hit the nickel crystal. ಇಲ್ಲೊಂದು crystal ಅನ್ನ attach ಮಾಡಿರ್ತಾರೆ. This is made up of the nickel. Okay, so the nickel crystal is there. So whatever the electrons are hitting the surface, they will get reflected. They will get reflected with different angles here. So ಬೇರೆ angle ಅಲ್ಲಿ reflect ಆಗ್ತಾ ಇರುತ್ತೆ. And here they are placing one detector. Here there will be one detector. So what this detector will do? This detector will identify with what angle these reflected electrons are coming anta helbodu. Okay. So here one galvanometer is also attached to this that is the detector. ಈ detector ಗೆ ಒಂದು galvanometer ಅನ್ನ attach ಮಾಡಿರ್ತಾರೆ, so that we can measure the current. So ಎಷ್ಟು current ಇದೆ ಅನ್ನೋದನ್ನ ನಾವಿಲ್ಲಿ measure ಮಾಡಬಹುದಾಗಿದೆ. Okay students, so here this is experimental setup of the Davison and Germer experiment. ಅಷ್ಟೇನ್ important ಇಲ್ಲ, just ನಿಮ್ಗೆ ಗೊತ್ತಿರ್ಲಿ ಯಾವ ರೀತಿಯಾಗಿ ಮತ್ತೆ ಏನ್ ಪ್ರೂವ್ ಮಾಡತ್ತೆ ಅಂತ. So the first point regarding the experiment is what? The Davison and Germer experiment determines the wave nature of the moving electron. So iden determine ಮಾಡುತ್ತೆ, it will determine the wave nature of the moving electron. Yes. So in the experimental setup, what we can see here, it consists of an electron gun. So illond electron gun ide, which comprises of the tungsten filament coated with a barium oxide, and iden electron gun ide, this they will heat it with the help of the low voltage supply. Okay, so the electron gun yavaga heat agatte, so the electrons will emit out from that surface. So when the electrons will emit out from the surface, here whatever the nickel crystal is there, it will reflect those electrons. So with the help of the detector, we can understand with what angle these electrons are getting reflected. Getting my point? So here the galvanometer is also attached to understand the current what the electrons are coming. So here with this experiment, suppose the wavelength of the electron, if they calculate the value of the wavelength of the electron, the value comes out to be 0.165 nanometer. 0.165 nanometer. Okay, so from the de Broglie, the wavelength of electron waves were found to be hagadre, according to de Broglie, the wavelength of the electron is the standard answer ide ನೆನಪಿಟ್ಕೊಳ್ಳಿ, it is 0.165 nanometer. Okay, so idu by the experiment they have calculated. According to de Broglie formula prakara calculate ಮಾಡಿದಾಗ ಅದರ value ಎಷ್ಟು ಬರುತ್ತೆ? 0.167 nanometer ಅಂತ ಬಂದಿದೆ. Okay, so therefore ನಿಮ್ದು experiment ಮತ್ತೆ ಇಲ್ಲಿ theoretical value, they are very close to each other ಅಂತ ಹೇಳ್ಬೋದು. Therefore the experiment confirms the wave nature of the electron. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? So according to de Broglie wavelength, the formula is what? H upon ನಿನ್ನೆ ನಾವೇನ್ ನೋಡಿದ್ವಿ, H upon mv ಅಂತ ನೋಡಿದ್ವಿ. Or in terms of charge also we have discussed the formula. So in terms of charge, it is H divided by under root of 2mq into v. So ಇಲ್ಲಿ q ಬದಲಾಗಿ charge of the electron ಕೂಡ ನಾವಿಲ್ಲಿ introduce ಮಾಡಬಹುದು. Okay, so in that case the lambda value ಎಷ್ಟು ಬರುತ್ತೆ ಅಂತ ಅಂದ್ರೆ 0.167 nanometer ಅಂತ ಬಂದಿದೆ for the electron. So same way illen ಮಾಡ್ತಾರೆ, Davison and Germer they will conduct one experiment for the electron beam. So idr prakara wavelength calculate ಮಾಡಿದಾಗ the wavelength is comes out to be 165 nanometer. So formula prakara calculate ಮಾಡಿದಾಗ ಮತ್ತೆ experiment prakara calculate ಮಾಡಿದಾಗ the values are very close to each other. Therefore iden wave nature of electron ಇದೆ, that is confirmed by the experiment that was conducted by the Davison and Germer ಅಂತ ನಾವಿಲ್ಲಿ ಹೇಳ್ಬೋದು students. Yes, any doubt is there here? So here one last point we need to discuss, that is the Bragg's equation. So you can note down, only the equation is there. It is called as the Bragg's equation. So what is this Bragg's equation? It is given by lambda is equal to 2d sine pi. It is 2d sine pi. Okay, this is Bragg's equation. So just remember the formula. Later we can use it while calculating some of the questions. Yes, students, this completes your that is dual nature of matter and radiation. Here some extra formulas we can take down. That is, just now we have, I told you about the formula, that is lambda is equal to, it is h upon under root of 2m q into v. Okay, so this is for the charge. Suppose if you are taking it for the electron, nimge idu v andre illenide, v is the potential. Okay, so v value gottilla, but h is constant, 2 is constant, mass of the electron is constant, and idenide charge of the electron is constant. ಆ case ಅಲ್ಲಿ the answer ಎಷ್ಟು ಬರುತ್ತೆ, ಇದು constant value ನೆನಪಿಟ್ಕೊಳ್ಳಿ. It is 12.27 divided by under root of v. This is in the angstrom. Okay, so this is in the angstrom. So just ನೀವು ಪೊಟೆನ್ಶಿಯಲ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಕೊಡ್ತಾರೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ, ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ವೇವ್ ಲೆಂತ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಎಸ್. Okay, yes, see here one more formula, students, that is the average kinetic energy of the gas molecule in terms of the wavelength is given by, it is lambda is equal to h upon under root of 3m k into t. So CET ಗೆಲ್ಲ ಈ ಫಾರ್ಮುಲಾಸ್ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ, ಸೊ ನೋಟ್ ಡೌನ್ ಮಾಡಿ ಇಟ್ಕೊಳ್ಳಿ. ಓಕೆ, ಸೊ ಇದು m ಅಂದ್ರೆ ಮಾಸ್ ಆಗುತ್ತೆ, k ಅಂದ್ರೆ ಇದು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಓಕೆ, t is the temperature, k is the kinetic energy. So this is formula for the wavelength in terms of temperature and kinetic energy. So one more point you remember or note down that. Here, see, they may ask you sometimes what happens to the velocity if wavelength is decreasing. What happens to the velocity if the wavelength is decreasing? So ಏನಂತ ಹೇಳ್ಬೋದು ನೀವು ಇಲ್ಲಿ? See, the formula is what? Lambda is equal to h upon m into v. So wavelength ಏನಾಗ್ತಾ ಇದೆ? Wavelength value is decreasing. Velocity ಏನಾಗುತ್ತೆ? It will increase because they are inversely proportional to each other. They are inversely proportional to each other. Yes. Okay, students. So now one more question I want to ask you. Tell me, what happens to the wavelength? What happens to the wavelength? Suppose V is equal to 0, or you can say that the body is at rest. The body is at rest. If the body is at rest, what happens to the wavelength? Yes, what happens to the wavelength? What will be the value of wavelength? So we have lambda is equal to h upon mv. ನಾನೇನ್ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, velocity is equal to 0. ಹಾಗಾದ್ರೆ lambda ಎಷ್ಟಾಗತ್ತೆ? See, one formula, if you are understanding, means you need to understand the physical meaning of the formula. ಅಂದ್ರೆ ಆ ಫಾರ್ಮುಲಾದಿಂದ ನಮ್ಗೆ ಏನೇನ್ ಗೊತ್ತಾಗ್ತಾ ಇದೆ ಅಂತ ಗೊತ್ತಾಗ್ಬೇಕು ನಿಮ್ಗೆ. Yes, tell me, students, what happens to the wavelength? See what it is, h divided by m into 0. M into 0 is nothing but 0. So any value divided by 0 is what? Yes, you people are able to hear me or no? There is no response from your side. So any value divided by 0 is nothing but what? It is infinity. So ಏನಾಗತ್ತೆ, when the velocity they are saying it becoming 0, the wavelength value is becoming infinity. The wavelength value will be infinity ಅಂತ ನೀವು ಇಲ್ಲಿ ಹೇಳ್ಬೇಕಾಗತ್ತೆ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? Yes. The lesson is clear, or you want me to revise any point? Understood or no?
Understood, ma'am.
Yes. So mainly what you need to remember in this lesson, that is what do you mean by electron emission. So electron emission andre the electrons are emitted from the metal surface. The phenomena is called as what? Electron emission anta heltivi. In the electron emission, we have four types of electron emission. That is field emission, photoelectric emission, light, that is thermionic emission, and the secondary emission. Okay, so adralli ನಾವು ಈ ಲೆಸನ್ ಅಲ್ಲಿ ಎದಕ್ಕೆ ಸ್ಟ್ರೆಸ್ ಮಾಡ್ತಾ ಇದೀವಿ? We are stressing for the photoelectric effect. So what is photoelectric effect? When the light of suitable frequency falls on the metal surface, the electrons comes out of the metal surface. This phenomena is called as what? Photoelectric effect. So ಇದ್ರಲ್ಲಿ ಕೆಲವೊಂದು ಟರ್ಮ್ಸ್ ಅನ್ನ ಕಲಿತೀವಿ. Like we study about the threshold frequency, we study about the threshold wavelength, we study about the work function. So threshold frequency is also called as cutoff frequency, and the threshold voltage wavelength is called as threshold wavelength. Sorry, cutoff wavelength. Okay. So similarly, we define the stopping potential. So stopping potential andre it is the some negative potential for which the electric current, photoelectric current becomes zero anta heltivi. That is called as the stopping potential. Similarly, ಮತ್ತೆ ಏನೇನ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ ನಾವು? On what factors the photoelectric effect depends, like intensity of light, frequency, wavelength, ಅದೆಲ್ಲ ಟರ್ಮ್ಸ್ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. And the graph nature, ಯಾವ್ದು ಪ್ರಪೋರ್ಷನಲ್ ಇದೆ, ಯಾವ್ದು ಯಾವ ರೀತಿಯಾಗಿ ಬರುತ್ತೆ ಅಂತ, that point we have discussed already. Then next, related to the de Broglie Einstein's explanation, we discussed about the Einstein formula, that is kinetic energy max is equal to h nu minus pi. So here nu is frequency, or we can also write it as hc by lambda minus pi. Okay, so ನಾನು ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೆ, ಎನರ್ಜಿ ಎಲ್ಲ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಾರೆ, we need to convert in joules. So the conversion factor is 1.6 into 10 raised to minus 19. So ಯಾವಾಗ ಏನಾದ್ರೂ 4 electron volt ಅಂತ ಹೇಳಿದ್ರೆ ನೀವು ಅದನ್ನ joules ಅಲ್ಲಿ ಮಾಡ್ಕೊಳ್ಬೇಕಾಗುತ್ತೆ. That is 4 into 1.6 into 10 raised to minus 19. Clear? So this is regarding the dual nature of radiation and matter topic. So here, these are the points which you need to remember along with the de Broglie hypothesis. So de Broglie hypothesis is giving you the de Broglie wavelength, that is given by h upon p or h upon mv. So ಈ ಫಾರ್ಮುಲಾನ ನಾವು ನಿನ್ನೆ ಆಲ್ರೆಡಿ ಬರ್ದಿದೀವಿ, ಯಾವ್ಯಾವ ರೀತಿಯಾಗಿ ಮಾಡಿಫೈ ಮಾಡಬಹುದು ಅಂತ. If you have any doubt in the lesson, please ask students. If there is no doubt, today and tomorrow we are discussing the numericals. Yes, please tell me, any doubt is there from the lesson? If you don't have any doubts, I can ask you some questions. We will discuss some questions now. Okay, okay, then be ready for the questions. How we used to discuss the questions, 1 mark MCQs and all that we will discuss now, so that it will be a revision for you. Then after that we can go for the purely numericals. Yes. So I want everyone to answer in the chat box. Wait, 1 second. Yeah, what happened? This. Yes. Okay. You are able to see the questions now, students. So you can answer the questions one by one. Work function is the energy required to produce X-rays. Is very good. So here the energy is required. The ejection of the electron from metal surface is called as work function of the cycle. So this is the correct answer. So the next question, it is based upon energy, momentum, charge. Yes. On which factor it depends? Photoelectric effect. Yes. It is based on the conservation of momentum. Okay, students. So it is based on the conservation of momentum. So that is option B is the correct answer. Are you able to see this? No. So go for the third question. Now you are able to see the screen.
No, ma'am.
Yes, now it is visible. See. So go for the third question. The photoelectric effect occurs only when the incident light has more certain minimum. Yes, what it should have, the more certain frequency. Option D is the correct answer. Go for question number 4. The maximum number of photoelectrons released in a photocell is independent. The maximum number of photoelectrons released in a photocell is independent. Nature of the cathode surface, frequency of the incident light, intensity of radiation incident on the cathode surface, none of the above. It is option C, students. It depends on the frequency, but it does not depend on the S. Option C is the correct answer. So it is independent of the intensity of radiation incident on the cathode surface. Okay. So intensity of light incident on photosensitive surface is doubled then. So the intensity of light incident on photosensitive surface is doubled. So intensity double adre, the number of emitted electrons tripled, the number of emitted electrons doubled, kinetic energy is doubled, momentum is doubled. Option B, the number of emitted electrons is doubled. Yes, everyone, same answer. Okay, option B is the correct answer. Go for question number 6, students. If the frequency of light in photoelectric experiment is doubled, the stopping potential will. If the frequency of light in photoelectric experiment. Yes, question number 6 we are discussing, right? Yes, okay. C, B. If the frequency of light in a photoelectric experiment is doubled, the stopping potential will become more than doubled. Yes, option C is the correct answer. Option C is the correct answer. Go for the question number 7. The best metal to be used for photo emission is. Yes, best metal used for photo emission. So we just require a metal surface, which is a metal in this. C, cesium. Yes, option C is the correct answer. That is cesium is the correct answer. Go for question number 8. De Broglie wavelength depends on the mass and energy according to the relation. So de Broglie wavelength lambda depends on the mass and energy. So if you remember the equation of the de Broglie equation, that is given by the de Broglie equation, lambda is equal to h upon under root of 2m mass and energy, 2m E into V. So here it is under root of ME is there. So therefore it is option A is the correct answer. Because option A the ಏನಿದೆ mass into energy to the power of -1/2. So numerator ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ? It will become -1/2. Correct? The kinetic energy of photoelectron is directly proportional to. So the kinetic energy is directly proportional to what? Intensity of light, difference between the frequency, the sum of the frequency, the ratio of the frequency. The ratio of the frequency of light used and the threshold frequency, sum of the frequency, difference between the frequency of the incident light and the threshold frequency. B, the difference between the frequency of the incident light and the threshold frequency. SB is the correct answer. Okay, go for the question number 10. If wavelength of an electron and a photon is same, then they will have dash same. Wavelength of the electron and photon. Wavelength same idre ಏನ್ same ಬರುತ್ತೆ? Yes, option B is the correct answer. Yes, okay. Option B, that is momentum is the right answer. Go for question number 11, students. A proton and an electron move with the same velocity. The associated wavelength for proton is. The proton and an electron move with the same velocity. The associated wavelength for proton is. So what they are saying here, that is wavelength is equal to h upon mv. The proton and the electron move with the same velocity. Andre velocity same ide. Hagadre wavelength ಏನಾಗುತ್ತೆ for the proton. So h is constant. V ಎರಡಕ್ಕೂ same ide. What about the mass? So proton and electron have the same. No, they are having the different mass. Proton mass is how much? It is 6.27 into 10 raised to minus 27 something. No, it is 1.67 into 10 raised to minus 27 kg. And for the electron, it is 1.9 into 10 raised to 9.1 into 9.1 into 10 raised to minus 31 kg. This is for electron. Electron mass. This is for the proton mass. So, hagadre wavelength enagatte? Yes, tell me. It is inversely proportional to mass. So, please tell me accordingly. Mass of the proton or mass of the electron, which is less? The values I have given you. See, the same as that of the electron. See here, the electron will have the greater wavelength than the proton, because the mass you can see, the mass difference you can see. So electronic ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಅದ್ರ ಪ್ರಕಾರ ನೋಡಿ, shorter than that of the electron, longer than that of the electron. Yes, it is option A, shorter than that of the electron. Option A is the correct answer. Yes, option A. Okay students, question number 11, option A is the right answer. Which of the following has the largest de Broglie wavelength if they are moving with the same velocity? ಸೊ ಕೊಟ್ಟಿರೋ ಪಾರ್ಟಿಕಲ್ ಅಲ್ಲಿ ಎದ್ರದ್ದು ವೆಲಾಸಿಟಿ ವೇವ್ ಲೆಂತ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ಆಸ್ ಯು ಹ್ಯಾವ್ ಸೀನ್, ದ ಮಾಸ್ ಇಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್. ಹಾಗಾದ್ರೆ ಯಾವ್ದ್ರದ್ದು ಜಾಸ್ತಿ ಬರುತ್ತೆ? ಬೀಟಾ ಪಾರ್ಟಿಕಲ್. ಎಸ್, ಬೀಟಾ ಪಾರ್ಟಿಕಲ್ ಇಸ್ ದ ರೈಟ್ ಆನ್ಸರ್. ಆಪ್ಷನ್ ಡಿ ಇಸ್ ದಿ ರೈಟ್ ಆನ್ಸರ್. ಸಿ, option D, beta particles have the largest de Broglie wavelength. So question number 13. If an electron and a proton have the same de Broglie wavelength, then the kinetic energy of the electron is. If proton and electron have the same de Broglie wavelength, yes, it is option A, more than that of the proton. Yes, option A is the correct answer, more than that of the proton. Option A is the right answer. Question number 13. Go for the next question, students. In photoelectric effect, the number of electrons ejected per second is directly. So photoelectric phenomenadalli, the number of electrons ejected per second directly proportional to wavelength, proportional to the intensity, proportional to the work function, proportional to the frequency. Yes, option B, sure. The number of electrons ejected per second. C or B or D? So it is option B is the right answer. That is, it is proportional to the intensity of the light. Okay, option B is the right answer. Go for the next question. Light of certain frequency and intensity incident on photosensitive material causes photoelectric effect. If both the frequency and intensity are doubled, the photoelectric current becomes. So frequency ಮತ್ತೆ intensity double ಮಾಡ್ತಾ ಇದ್ದೀರಾ, photoelectric current ಏನಾಗುತ್ತೆ? What happens to the photoelectric current? Yes, option C. Yes, very good. So the photoelectric current also doubles. Option C is the right answer. Go for question number 16, students. When a green light is made incident on a metal, photoelectrons are emitted by it, but no photoelectrons are obtained by yellow light. If red light is made to incident that metal, then. So here what you need to think is, that is the color sequence you need to think. So if you remember the color sequence in the spectrum, this is V, I, B, G, Y, O, R with diode, right? So according to this color sequence, what they are saying here, see, ಯಾವಾಗ green light ಬೀಳುತ್ತೆ, VI, B, G, this is G. Okay, green light ಬಿದ್ದಾಗ you are able to see the photoelectric effect. Okay, the photoelectrons are emitted by it, but no photoelectrons are obtained by the yellow light. So yellow light in the photoelectric effect possible ಇಲ್ಲ. ಹಾಗಾದ್ರೆ red light ಬಿದ್ದಾಗ ಏನಾಗತ್ತೆ? No electrons will be emitted, less electrons will be emitted, more electrons will be emitted, none of this. Yes, option A, that is no electrons will be emitted because ನಿಮಗೆ photoelectric effect ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ಬರೀ green color ವರೆಗೆ ಮಾತ್ರ ಬರ್ತಾ ಇದೆ. Above this frequency it is not showing. So ಹಾಗಾದ್ರೆ ಎಲ್ಲೋದ್ ಮೇಲ್ red ಇರೋದ್ರಿಂದ with red also it is not possible. So no electron will be emitted. Option A is the correct answer. Go for the question number 17, students. Go for question number 17. The value of E by m was found to be independent of the value of E by m. That is charge of the electron upon mass of the electron. Is independent of the nature of the material, gas introduced in the discharge tube, both A and B, none of this. It is B, that is gas introduced in the discharge tube, or whether it is A. It is independent of, they are asking, right? Okay, I am thought it is depending on. So independent of the gas introduced. So option B is the right answer. Go for question number 18. The electromagnetic theory of light failed to explain. So the electromagnetic theory was failed to explain this photoelectric effect. Okay, so photoelectric effect anna explain madalla because it explains the wave nature. So photoelectric effect is the particle nature. Photons are electrically. So photons are electrically, photons are nothing but energy packets. So electrically, positive, negative, neutral, all of this. C, it is neutral. Yes, option C is the correct answer. So photons are electrically neutral. Okay, students, the last question for the today's class. So remaining questions we are seeing in the next class. So question number 20. Go for question number 20. So what is question number 20? C. I think so you did not study this experiment. R.A. Millikan performed the pioneering oil drop experiment. Okay, this is not there. It is deleted. So leave it. So last question you go for question number 21. The minimum negative potential applied to the anode to stop the photo emission from the cathode is called stopping potential, threshold frequency, work function, threshold wavelength. What it is called as? It is called as stopping potential. So option A is the right answer. Okay. So the remaining questions we will continue in the next class. Meet you in the next class, students. Thank you. Bye.